So this talk is about Mongoose. It's actually about something bigger than Mongoose. And at the time it was the lightning talk, we were really just going to talk a little bit about some problems we ran into. But what this is really about is a story about how we made a series of really good decisions, you know, not things that even in retrospect I would critique, that ended up over time kind of cornering us, right? So you start out with these nice, cute mongoose puppies here. You come back as an innocent snake, making your way in the world, thinking you might eat one of those puppies, and that's what you're confronted with. To start out with, just a bit of background. Who here has actually used Mongoose? So, okay, quite a few people. So I did make a slide just in case anybody didn't know what it was. It's basically, this is just a screen grab straight off the website. It is a modeling tool for MongoDB, right? So you can basically create models. It gives you a lot of really powerful functionality, and it also it wraps a database driver. So it's both a modeling tool and a database driver, and that's important. I'll be coming back to that in a moment. I'm going to talk just briefly about who we are, what we're doing, where all this stuff fits in. First of all, this is the company I work for. We're called Sentry Technology. We're an ed tech company. A few of my colleagues are out in the audience, and we are developing an education platform. So we're already delivering in quite a large number of schools. People are doing their homework on our platform. Teachers are delivering lessons and that kind of thing. This is our stack. And so where Mongo fits, well, it's right there. But actually what happens is, and all of this is important to this story, right? Because this is all about the way that our platforms evolved and the way that this really, really good tool, Mongoose, that allowed us to connect to Mongo and manage our entities, came to cause us problems. So we've developed our front end using web components with Polymer. Who here has experience using components in any form on front end? So you'll have an idea of some of what I'm talking about a little bit later on. We use Typescript. That is also going to figure into this story. We have a set of front-end APIs, which are microservices developed in Node, right? That's why we're here at this forum. We have back-end APIs that are doing all of the machine learning and data crunching and that kind of thing. Those are developed in Scala, also microservices. The back-end APIs talk to Cassandra. When they need to interact with Mongo, they go through the front-end APIs. And that's our stack. This is actually an even bigger problem. And this is the one that sparked the initial set of thinking that basically led me to propose the lightning talk way back when. We had a discussion. I don't know exactly how serious it was. It was one of those things where it was serious, but we weren't really going to do it. We started talking about whether we might want to switch to another database. And that has to do with a lot of things, but one of them is the evolution of our overall data design. It's become more and more relational as time has gone on. And as anybody who's used Mongo knows, it's not really a very good platform for managing relationships between data. You have to write a lot of that stuff up in the application when a SQL-based database, like say Postgres, which also allows you to have schemaless BSON fields in it, would manage those relationships for us out of the box. And we started thinking about that. Now, I mean, switching to another database is not a trivial task under any circumstances. But if you've got a package like Mongoose that basically combines your database driver and your data access layer with your models, suddenly you've got two parts of your application that have to be completely rewritten in order to accommodate a change like that. And that's when we started thinking about the limitations of this tool, that what it was giving us out of the box was also tying us to one piece of tech in our stack, whether we wanted it or not. And as I say, I don't know how serious we've ever been, whether we'll ever switch to another database, but that's when we started thinking about that. And that's when the first set of problems started coming back, and we started thinking about this in light of that, and started thinking, well, maybe this is just something we want to start moving on from. Now, the reason I talked about our stack is how that plays into this whole situation. So when you develop components on the front end, you can think about those as kind of like microservices for the front end, right? Each one of them has its own scope. It's almost like developing a whole cluster of tiny little applications that each have to interact with stuff in their own way. Each have to import certain resources. Each have to exist in that way. So spreading the schemas among all those components, spreading the types among all those components, doing all of that kind of stuff was a big headache. And having all of the schema definition concentrated again in the one layer was causing us a big problem. So we started thinking about a solution to our problem. And so that's why I'm saying this is not actually a talk about flaws in Mongoose so much as focusing on Mongoose as an example of a problem. So first of all, thinking back again to the fact that I didn't even mention this at the time on the slide, the Scala APIs have their own data definitions, and those are totally not shared with anybody. And in fact, really all schema definition, because 2 years ago we were a startup, is still happening in a Google Doc. And so we want to move on from that. And so what's happening now is we've got a repo of JSON schemas for all of our entities, everything, even the stuff in Scala. So what the Scala developers do to actually consume that is totally up to them. But basically, the data architect writes those schemas. We write them with her if when we need to do input. And then what's in the repo is basically the entity definition, and that can be exported out. So we've then begun the process of splitting apart modeling from data access. So we are going to phase out Mongo altogether. We're going to write a new data access layer. We're looking at a couple of packages for doing that, and we're going to do that in such a way that if we do make that decision down the line to swap to another back-end system, it's not going to affect any other part of our code. We just write maybe some new access code and put that in underneath the models. And most importantly, we've started writing agnostic model classes that we can use in all parts of the JavaScript parts of the application. So basically, they're base models that can operate on the back end and the front end indifferently. We don't use anything like Browserify or any of those kind of build tools. So the idea is that you extend these. So on the back end, you extend, I'm going to show a code example in a moment. You can extend it on the back end, and all of the dependencies can be imported using back-end imports. And on the front end, you can use HTML imports, which is what we're using for the moment, till we switch that as well. So finally, we found a really good plugin that we can use to take all those JSON schemas and convert them into Typescript. And that's what I'm going to just show in this example. So bear with me for a moment. Oh, wow, it landed on the right one. So this is an example of one of the agnostic models. This is based on a really, really simple instance of a user. There is also another one that is showing the JSON schema on the left. So the JSON schema there for this user is defined there. When you run the build tool, this is what you get as an output for your typings that you can import. So this would be sitting on top of the repo that we're going to have, which is going to be exporting JSON schemas. And we still haven't quite worked out how we're going to deliver those to the real world. But this thing will basically conduct a build on that, create a set of typings that we can then import into any classes that we're using. And then this is an example of a base class. So again, it's not pulling in any of its dependencies. It's declaring all of its typings everywhere. It's implementing the output that we got from the JSON schema converted to types. It's declaring all of its public interfaces down there, and then it's got methods. And this is an example of how you extend it on the back end. So I do my imports up there, and then I just declare those in the constructor. And so by doing that, we're basically going to be able to do identical validation code on the front and back end. So ZSchema, which is the plugin that we're using to do JSON schema validation, works on the front and back end. They provide you downloadable versions for both. And we can therefore have identical code running. So if you think back to the Mongoose situation, if we wrote another class to do front-end validation, we've now got completely different code doing our validation on the front end and the back end, and that is obviously a maintenance overhead. So that's basically the talk. It's about halfway between a lightning talk and a full talk. And it's, as I say, it's really a story, I think, from our perspective about making the right decisions and still having them blow up on you, and then trying to figure out a way to get out of it. So I guess I can open up for questions if anybody has any. Otherwise, well, thank you very much.